Hi class, the first topic of this week is going to deal with a little bit of review of integers. And the idea is just so that we have a perspective on how to represent negative numbers and how to explain some of the properties of the negative numbers. So before we go any further, when we refer to the integers, we're actually talking about this set over here. So technically, all the numbers on the number line, and at the moment we're ignoring decimals and values such as square roots and so on. And keep in mind that, well, from day one, we talked about the natural numbers, which is part of a subset of the actual integers. Here you have a couple of the properties, which they're basically saying if you have a positive value, you add its negative, well, technically the result is going to end up being 0. And then one of the main properties that we have to go over in this section is the idea of the absolute value. Now, the basic idea of the absolute value is the distance of any number to 0. If you ever cover the actual definition, it's a little bit more complex to actually get the idea across. So I think the best is if you just reference it back to the distance of any number to 0. I think it'll be easier to explain as opposed to basically if you go into the definition, especially because the way that we express the definition, it looks like one of those piecewise defined functions. Now, let me take a look at example 1. And in example 1, all they're asking is for us to basically evaluate and graph. Now, if you're going to evaluate this first example, we're basically just saying absolute value of 4, or what's the distance of 4 to the value of 0. In this case, this is equal to the values of 4. So that would be the actual evaluation. They are asking for a sketch, and keep in mind that we're dealing with, well, the actual distance of any number to 0. So for this particular one, since we're just looking at absolute value of 4, which is 4, we're just going to be placing a dot on 4, and then technically it just represents, well, a dot at 4, and from the actual value of 0, we're moving a total of 4 units to the right. Now, the next problem, we're looking at absolute value of, in this case, negative 4. And remember that absolute value represents the distance of any number to 0. So in this case, you're just going to end up with the values of 4. Negative 4, it's technically 4 units away from 0, but on the opposite direction. So in this case, we're looking at negative 4. The actual sketch, it's there. You may or may not want to include the arrow. Your final answer is the actual dot, and I'm referring to the dot at negative 4, in this case here, negative 4, or the dot at 4. I decided to include the actual arrow along with, well, the dot. This is because we're going to be doing addition pretty soon. Okay, let's go to the next one. And on the next one, we're looking at, well, the multiplication of 2 times the absolute value of negative 4. So as you simplify this one, this is still 2 times the absolute value of negative 4. And I'm just going to put I'm just going to underline it. And if you evaluate, in this case, the absolute value of negative 4, this is going to be, well, the values of 4. And our final answer, it's actually going to be the values of 8. So that's going to be our final answer. Our sketch of this one is just going to be at the dot of 8. And then in this case, I'll just put the arrow. No addition. Overlooking it is a couple of evaluations of the absolute value. Okay, let's take a look at the next one. And you need to be a little bit careful as we evaluate absolute values. In this case, this is equivalent to a negative 2, but we're about to evaluate the absolute value of negative 4. So we're looking at absolute value of -4, it's 4. That happens to be this answer there. And then our final answer for this one, it's going to be -8. So in this case, we're simply looking at a dot at -8. And then I'll just put the arrow. That's pretty much it on the absolute value. As you're explaining this to your students, I would always recommend to, as you're explaining these basic problems, to always go back to the idea of distance. I think it's much easier to understand that if you were to explain, well, the actual mathematical definition in terms of what absolute value represents. Let's go to the last one for this example, and let me actually rewrite it. So in this case, we're looking at this expression happens to be the same as, well, the values of 5 plus technically 2, which happens to be the absolute value of -2. And then we still have a plus 6. And then a -4. And this one actually copied in this format, but that's not an absolute value. That's an actual bracket. So this is going to be a times 2. Or the values of 5 plus 2 plus 6 minus the values of 8. At this point, you can add them in any order. So let me just add the first 2 and the last 2. So we're looking at this is equal to the values of 7. 6 minus 8 is equal to -2. So plus -2, or our values of 5. And then as we provide the sketch, you're looking at 5 as your final answer. That would be it. In terms of the instructions, they're referring to evaluate, then your final answer is the one that you're graphing. So they're not looking at an actual expression as you're technically, well, repeatedly adding like the 2 and the 4 to get the 8. Let's take a look at the second example, which basically it's the continuation of the problems that we did on example 1. And this is what you're looking at in example 2. So they're introducing variables. And for these problems, as long as what you're trying to evaluate, in this case, the value of 3 happens to be a positive value, then all of your equations are going to have a solution. So in this case, we would have said x is equal to the values of 3, or x is equal to -3 as our final solution. And then the actual dots, in this case, I'm just going to put the dots. Let me use a different color. So our final answer is going to be 3, and technically -3. Those would be the only unknowns that if you take the absolute value, the answer, you're going to get the values of 3. So this happens to be our final answer. I'm going to box this one in just because of the next actual question. And you have to be very careful on all of these problems. We talked about these when we talked about equations at the beginning of the semester, but here we have a minor problem. We're trying to find which distance, or in this case, absolute value, happens to be a total of -3 units. Now, remember that within the basic definition, we talked about absolute value being a distance. So all of your distances, the minimum that they're going to be is the value of 0. So therefore, for this one, you're basically going to say no solution. And your final answer is going to be the empty set. The reasoning being is because you technically have a negative number Now, if the instructions say to box your final answer, in this case, this is going to be your final answer. So you still come up with the number line, but there is no actual dots on the line. It has to be clear that we're talking about an absolute value. In this case, equation. Let's go to the next one. And on the next one, we're looking at, well, the following two conditions that we need to check. That is x plus 5 is equal to 4, or the values of x plus 5 is equal to negative 4. And each of these, we're going to end up solving independently and technically checking. So as we solve the first one, we can simply subtract the 5. And on the second one, also subtract the 5. And I actually have an error here. It's supposed to be negative 4. So as we look at the first solution, x is equal to 4 minus 5. We're getting negative 1 on the first one. And technically, our final answer is going to say or. And as we look at the last one, x is equal to negative 9. So our final solution is going to be a negative 1 or the negative 9. And let me just box it in so that it's clear that we're technically looking at, well, the following solutions. And the idea is if you were to plug in negative 1 plus 5, that's 4. Absolute value of 4 is equal to 4. If you plug in negative 9 plus 5, you're going to get the absolute value of negative 4, which simplifies to 4. So all of these contain a total of 2 possible solutions.